Hello, my name is Staggs. I'm HVAC instructor at Caddo Kiowa Technology Center, and today I'm going to show proper techniques on how to solder copper together and pressure it up to make sure that it doesn't leak. So our first thing that we do is you take your tubing cutters here and you cut your copper side however length that you want, and use fittings if you want, or you can use a wedging tool to make them fit together. This copper is 3/8 inch copper, and I've pinched off this side right here and soldered that closed, and I put a Schrader valve in here so we can put nitrogen pressure on it after we're done. On your torch set right here, oxyacetylene. This is acetylene here. This is your oxygen bottle, it's green, and you turn them both on. One side of the gauge tells how much pressure is in the bottles, and the other side of the gauge is how much pressure is going to come out of your torch. And on the oxygen, it's supposed to be set at 10 pounds pressure. Acetylene should be at 5 pounds pressure. And I've got to adjust that oxygen. All right, that's about right there. Now when you're lighting your torch, if you just turn the acetylene on and light it, you'll get little black flecks of stuff in the air floating around. And you don't want to do that in someone's house, especially a woman that's got white carpet. You want to light the torch where it comes on with oxygen and acetylene both. I like to hold my torch like this with one hand, and I can control my gas and then my oxygen with this finger right here. So first I turn on the gas, a little bit of oxygen, and it lights like that. Then you can adjust it down. Not too high. Want your torch to have a blue-green cone right in the middle of it, just like that. That's a pretty good flame. And you want to heat both pieces of metal up first, and then after it's heated, keep your flame on the side that you want the solder to flow. This is 15% silver solder. You want the copper to melt the solder, not the flame. You can move that solder around with your flame. It'll move with the heat. Always turn your acetylene off first, and then your oxygen. You want to take a mirror and inspect your solder, your joint. Make sure you got it sealed up. A solder joint that looks good has a shoulder on it, right there where the fitting meets the copper that you've soldered onto it. After that's done, you need to cool it off so you can touch it, work with it. Use a wet rag, cool it off. If you have a component that you need to protect while you're doing soldering, we use heat shield on it. You just spray it on there. It's gel, it sticks to that, and it keeps whatever valve or other component that you're trying to protect, keeps it cool. You can also use wet rags to keep those components cool as well. That's the old style way of doing it, wet rags. Keep that heat from moving where you don't want it to. That's what your skin will sound like if you touch it while it's hot. The reason for cooling that off before you work with it any further also is this is called a Schrader valve, just like what you'd use on your bicycle tire. And it has a valve core in it. That valve core has Teflon seal right there. If you were to get that hot, it would melt that and it wouldn't seal, or it would get stuck in there and you couldn't get it out. Screw it all the way down in there until it won't tighten anymore. Then next, you want to pressure it up with nitrogen. See if it holds pressure, if you got any leaks. So we'll hook up our gauges, turn on our nitrogen bottle. This gauge tells how much is in the bottle itself. This tells how much pressure you're getting in your gauges. And I like to test mine with at least 150 pounds of pressure and leave it for just a little while to see if it holds. So, put this on there. That's our refrigerant gauges that I'm using. After you turn the nitrogen on, you need to bleed the air out of here. So, take and bleed it just a little bit, and turn it on. Might be here, I've got a leak somewhere. That's it, it sure is. Okay.
I saw the dust come out.
Yeah. Saw the dust come out. So to make sure that that's sealed up, we'd have to light the torch again and seal that up. And then we'll do that. Make sure that we get a good tight seal. And that right there is far enough away from your Schrader. The heat won't have time to move up there to it, so you don't have to take it back out again. All right, let's try that again. All right, so you can see on the gauges, we got it at about 150 pounds, but if it's not quite there, you can turn it up a little bit if you want. Some manufacturers require you to pressure your systems up to 600 pounds of pressure to make sure there are no leaks. Okay, next we use some Bird Dog leak detector. In spray, it's just soap bubbles, but it's a different formula than just regular Dawn dishwashing soap. It doesn't corrode the copper. If you just use Dawn soap and water, it would corrode the copper. Then you just look around it for any bubbles. That Bird Dog will show you if it's leaking or not. So if everything's sealed good, no bubbles, then you know that your system's going to hold the refrigerant, not leak it off. And it should hold like that for many years to come. And that right there is soldering copper, the silver solder. So thank you for your time, and I hope you enjoy this video.